On the bench is a Kenwood TS-450S. This is a radio that I've just recently acquired for a reasonable price. At the point of pickup, I did a quick test, living it up with 12 volts, and the receiver was making, white noise, so it sounded healthy, and I figured it was still worth the risk. However, once I've got it back and switched it on, the receiver is dead. The AF gain, no response. So I'm going to have a look at it. I am hoping that it may be in the audio section. I've sort of reasons to believe that it might be, the fact that it's completely audio dead. So I've got a sniffer amplifier, so I'm going to trace it back through the audio section until we find some signal, and then work out what the repair is. So the next thing to do is open up the radio. Disconnect the 12 volt dummy load. Okay, there we go. So we're looking at the underside of the radio. And we'll just get the schematic out, have a look at whereabouts we actually are. Okay, had a little bit of a look at the schematic diagram, which is up on the screen now. So we're looking at IC5 is the audio chip. So I'm going to check the input to that chip. Interestingly, it is a common Kenwood chip, and I do have a replacement, so I'm pretty happy about that. So I've just got on my, this is the little sensing amplifier. So one side will be to ground. We're picking up a little bit of radio in the head broadcast there. Switch on the receiver. Now, ground that kills it. Pin 1 is the input. Okay, we had to mute up there a bit. Alright, so we seem to be getting some signal in there. Okay, I'm adjusting the AF gain. Okay, so that seems to indicate some input. Nothing much on that. So this is a good sign, I think. It's either this chip.
How long would that continue, that sort of those rolling 3 weeks doing something?
Turn the amplifier off. Have a look at the schematic. It looks like we've got a bit of a flash mark on the board there. Not sure if we can pick that up. Going to put a bit more light on that. But what I'm looking at, just turn the radio off, seems to be, yeah, there's some, it's not a flash mark, it's actually goo that's maybe come out of this capacitor, although the capacitor's not showing signs of rupture, that's all intact, but I'm not sure where else that would come from. Okay, so what do we got? C104, C104. So let's have a look on the schematic. So C104 is in series with the speaker. So, okay, well, what I'm going to do is take the board out and see if we've got one of those in stock, replace it, see what happens. Have a look at some of these other electrolytics, although they look pretty good. But so did that one until I had a close look. Alright, okay, so the next thing to do is to get the board out. I'll just take a few photographs of where all the jumper leads go. Pretty... Okay, so this is a separate board, so let's have a look. Yeah, I didn't capture all that, but that loom has been disconnected, which is now working. Some of these are a little difficult to get out. I'm always a bit nervous about forcing them, so that's just an internal link. We'll leave that one. This one comes out pretty easily. Just work them. Leave that one to last and we'll figure out how to do him. Take this one out the other end. Yeah, that's a bit easier. Okay, so I think that's got all these. I've just got these ribbons, which I'm not entirely sure how they come out. Okay, I think these are just okay, simple enough. Okay, so I think that is now entirely free. Four screws. Yeah. Couple around the board. Oh, another screw over here. Six screws. Okay, that's 6 screws removed. And looks like that's coming out. Just get out of the way of the loom. Okay, we've got the circuit board in the jig. So we're going to start with C104. Okay, these are leads from the electrolytic capacitor we're removing, and I'm not sure how clear this is, but in between there is a very small surface mount resistor. So in removing it, I've got to be sure that we don't dislodge that, which just make life more difficult. Tighten it up a bit. Try the other side. Now this is more difficult because we're now closer to this surface mount resistor. Make sure we're tugging on the right component. Okay, again, not sure how clear this will come up, but you see he's looks like it's blown out the back to some extent. We'll have to just see if we can move the camera. A bit of residue on the boards. We're going to make sure we clean all that up. I believe that can be corrosive to the tracks. I'm not 100% sure on that, but I have heard that somewhere. So we're going to clean it up anyway. And I have actually found a 100 mm similar, well, same value electrolytic capacitor, but a slightly higher working voltage, which I think is actually good. Alright, we'll clean that up. Still seems somewhat moist, so maybe this thing has failed. Well, quite likely it's failed very recently, like as soon as I got the radio. Okay, we're just thoroughly cleaning out any of the electrolytic capacitor leakage residue. It is fairly clear to see that it's actually reacted with the printed circuit board mask, the green mask. It's exposed the copper, so I'm quite happy to get rid of as much of this as I can, if not all of it, so that it doesn't react with the track. The cotton buds so far have removed quite a bit of material, so I've continued cleaning until essentially nothing more is coming off. Makes me reasonably satisfied that it's as clean as I'm going to get it. So I'm just using a PCB wash compound. Before I attempt to install a new capacitor, I'll just clean up these through holes. Okay, that was a bit of work to actually clean out the through holes. A bit of solder in there. Use the solder wick with a bit of flux to clean the residue solder out. So I'm going to put the electrolytic capacitor in, making sure the polarization is correct, so it's positive that side, negative this side, and push it into the through holes. Quite snug. Okay. Okay, I'm happy with that. So there's no indication that these two electrolytic capacitors are giving any problems, but I've got the board out. I've located some replacements, so I'm going to do these two as well, and then the board will go back in. We'll determine whether the repair has been successful. The other possibility is the amplifier chip here may need to be replaced. Unfortunately, I do actually have one in stock. It's a common of this era Kenwood radio. Just use the solder wick to get this off. There's not much there for the solder sucker to pull out. So just putting a bit of flux on the I've got a bit of solder flux on the wick. Okay, again we're putting in the replacement 330 microfarad capacitor. So I'm just having a look. The original had a (16) working volt. This one's 25, so it should give a bit more margin of protection is my theory. Okay, and this one we're replacing is a 470 microfarad 10 working volts. We're replacing it with a 470 microfarad 16 working volts. A small amount of flux with the flux pen, just to ensure that the solder draws into the through hole. A little bit of PCB wash solution, get rid of the flux residue. Okay, we're now about to put the board back in. Screw number 5 up to screw number 6. The connectors look in good shape and nice and clean. Just giving them a quick squirt of contact cleaner to be sure. And this one was actually hanging there, so it's just there to distress you.
Okay.
It's like we're ready to go. Well, that's the sound we want to hear. Okay, we just assemble the bottom cover and connect it up. With the repairs completed on the Kenwood TS-450S, the radio is connected to the antenna system, has power available.
So yeah, no, the car's packed. I've got my QRP, I've got the 703 in the back of the book.
Receiving nicely on the 40 metre band. Alright, that's the completion of this work. Thank you for watching.